Good day, sir. I am Jason James M. Okno, and I'm going to talk about the introduction to programming. So, here's an overview. People have always followed order steps to do things. Think about following a recipe to bake a cake. You mix things in a certain order to get the cake you want. This idea of doing things step by step is important for computers too. During World War II, women called computers did math problems by hand for the army. They figured out things like where a bomb would land. They had to follow specific steps to get the right answer. When computers were invented, people could teach them to do these math problems. They took the steps the human computers used and turned them into instructions for the machines. These instructions are called algorithms. An algorithm is just a list of steps a computer follows to get something done. When we write these steps in a language the computer understands, a programming language, it becomes a computer program. The program tells the computer exactly what to do to get the results we want. So whether it's baking a cake or calculating a bomb's trajectory, following steps is important whether a person or computer does it. So programming to development, no. Sa sa introduction, sir, as an overview, no, programming isn't just about writing code. It's a cycle where you plan, write, test, and improve the program to solve a problem effectively. Mm-mm. So, programming to development cycle. The programming development cycle is a structured process of creating and refining a program to solve a specific problem using a computer. It begins with designing an algorithm, which consists of step by step instructions arranged logically. However, programming does not end once the code is written. The program undergoes continuous refinement and testing to ensure accuracy and efficiency. This cycle repeats as needed, ensuring that the output meets expectations and that any issues are resolved, making the it continuous process of improvement. Also put, the development cycle has these steps. Steps embracing cycle which will guide programmers in developing problem. No, define and analyzing the problem. No, mag-analyze gid tag problema, planuhon ang designs, unsa ang solution. Oo, to code the solution, testing and debugging the solution, implementation, and maintenance and documentation. To better appreciate the aforesaid steps, let us consider figure 1 to 1, which shows the visual representation of the programming cycle. So here is the figure 1 1. No, as you can see, number 1, defining and analyzing the problem. Number 2, planning the solution. Number 3, coding the solution. Number 4, test and debug the solution. 5, implementation. And last, 6, maintenance. And so on and so forth. Mubalik gid siya sa 1. Then sunod-sunod na siya sa 1, 2, 3, 4, and 5. 6. So, defining and analyzing the problem. Defining and analyzing the problem is the foundational step in software development. Laying the groundwork before constructing a building, it involves more than just a vague notion of what needs to be done. It requires a precise articulation to the problem itself. Like for example scenario, a daughter receives 10,000 from her mother for school fees with a strict instruction not to spend it on anything else. However, she spends 5,000 pesos on replica designer bags. Now she only has 5,000 left for school fees and she needs to find a way to make up the shortfall without asking her mother for more money directly. So defining the problem, the core problem is the 5,000 pesos. The deficit for school fees caused by spending half of the money on non-essential items. No, analyzing the problem is that the daughter can break down the problem to explore potential solutions. No, amount needed. The exact money needed is 5,000. Time frame, when are the school fees due? No, this will determine the urgency of the situation. Potential sources of funds. Can she borrow from friends or relatives? Can she take on a part-time job or sell something? Repayment plan. If he borrows, how and when will she repay the loan? Splitting the problem, as the image shows, she can further break down the 5,000 into smaller, more manageable amounts for Example, she could aim to borrow 500 from 10 different people. This approach makes the task less daunting than trying to find 500 at all at once. No? Finding a solution. By analyzing the problem and breaking it down, the daughter can explore different avenues. She might create a detailed list of everyone she could potentially borrow from, or explore online platforms for part-time work. She can also assess the feasibility of each option based on the time frame and her ability to repay. In essence, defining and analyzing the problem, including breaking it down into small parts, is crucial for effective problem solving. No? So, as you can see, sa defining o analyzing sa problem, dapat yun imo siyang huna-hunaon o unsa o imo gi-define, imo gi-analyze ang problema, no? Mangita gyud kag solusyon, mangita gyud gadaan. Planning the solution. Imagine trying to build a house without any blueprints. It would be chaotic, right? The walls may not line up, the plumbing could be a mess, and the whole thing might collapse. Planning and programming is like creating those blueprints. It's where you map out how you're going to solve the problem you've defined. No, planning is crucial. It involves figuring out the logical steps needed to achieve your goal. This saves time and effort in a long run. A good plan acts like a roadmap, guiding you through the development process and helping you make informed decisions along the way. Good programs are the result of careful thought and methodical execution, not just random typing without a plan. You're risk writing a lot of code that doesn't actually solve the problem efficiently or even at all. Ang sa finding a solution, after analyzing it, also no sa kang Alice, ang nangita siya on how can make a peanut butter and jam sandwich with a general instruction like make me a peanut butter and jelly sandwich, jelly. Alice understands the implied steps. Get the bread, peanut butter jelly, a knife, and then assemble the sandwich. She can adapt it to jelly chunky or if she prefers a specific type of bread. So, mo yung algorithm, precise instructions for a computer algorithm, mo na siya. A computer, on the other hand, needs a specific algorithm. So, need mo siya og specific instructions para ang computer musunod sa imong gusto. So, I can see na ay 20 steps here. Go to the pantry, locate the bread, and take out slice of a bread. Place the bread slices on a plate. Locate the peanut butter jar. Open the peanut butter jar. And then the key differences is the level of detail, adaptability, context, and key similarity. Computers are incredibly fast at following instructions, but they aren't smart like humans. They can't understand the world or figure things out on their own. They rely entirely on programs, which are just lists of very specific steps. Even though computers can do billions of these steps per second, they still do them one at a time. It's like a super fast robot. It can move quickly, but it needs to be told exactly where to move each leg, arm, and finger. Think about making a paper airplane. A human can understand the instruction, make a paper airplane, and figure out the folding steps. A computer needs a program that lists of each fold. Fold the paper in half lengthwise, fold the corners down to the center, etc. Even though the computer can execute these folding instructions much faster than a human, it still has to do each fold one at a time. It can't skip steps or figure out a new way to fold the plane unless it's been programmed to do so. So, mapa ni siya. Kung unsang imong i-program sa computer, iya gyud sundon dili siya mo skip og instructions nga imong giputang. Modeling tools. Before writing a computer program, it's helpful to plan out the steps using a tool like pseudocode. Pseudocode is like writing out of instructions in plain English, but with a little bit of structure. It's not about actual code that the computer can run, but it helps programmers organize their thoughts. So this is an example of pseudocode. This pseudocode outlines the basic steps in a way that's easy to understand once you have the pseudocode. It's much easier to translate it into a real programming language that a programmer can understand. So the use of flowchart. The use of flowchart are graphical representation of algorithms. They use symbols to represent different operations and arrows to show the flow of execution. Flowcharts are particularly useful for visualizing the logic of a program, especially when dealing with complex decision-making processes. Flowcharts also provide a clear visual representation of the program steps by making it easier to understand and debug. Both pseudocode and flowcharts are valuable tools for programmers. They help bridge the gap between human understanding and the precise instructions that computers require. They allow programmers to plan their code effectively, communicate their ideas to others, and to ultimately write more efficient and reliable programs. So this is so mo ni siyang example sa flowchart na siya start, get the rest mo na siya. So in the other video na explain ni siya unsa ni unsa ni siya ang flowchart. Number 3, coding the solution. Coding the solution is a critical stage in program development where the procedure outlined in pseudocode or flowcharts are translated into language the computer understands. It's the essential step that transforms a planned solution into a working program. While pseudocode and flowchart serves as valuable tools for organizing the program's logic and steps, they are ultimately meant for human comprehension, not for direct execution by a machine. Coding involves using a specific programming languages, with its own syntax and grammar to express the algorithm in a way that the computer can interpret and process. So, coding is a crucial stage again in software development. Okay, where the logical procedure defined through pseudocode or flowcharts are transformed into format that computers can understand. So this is the compilation process. After coding a program must be compiled to generate executable code. The source code written in English like statements is translated into object code by compiler, which the computer can execute. From source code to compiler to object code. Number 4, testing and debugging the solution. Testing and debugging the solution is a critical phase in software development where the written code is rigorously evaluated to ensure it functions and correctly and meets the defined requirements. Testing involves running the program with various inputs, including edge cases and expected data, to identify any discrepancies between the intended behavior and the actual output. This process aims to uncover errors or bugs in the code. Debugging process. Debugging process of finding and fixing errors in a computer program to ensure it runs correctly. Mo nang naa siya debugging kay para makita ang mga error or ang bugs to ensure nga mo run siya correct. Ang test run. Test run is a process of executing a program to check if it functions correctly and produces the expected results. Ug mag-program ka, mag-code ka, syempre you have to test it run kung makita nimo tama ba ang iyang mga functions ug mo-produce ba siya og imong expected results. 5. Implementation. After the program has undergone rigorous testing and has been confirmed to function correctly with real-world data, it is officially ready for actual use. However, before full deployment, it enters a supervised trial phase that typically lasts for 3 months. During this period, the program runs under close observation to ensure that it produces accurate and reliable results. So, ang kaning implementation, makita gid nimo diri ana ang imong makita na ang imong program nga working. It's ready to be used but before full release. It goes through a trial phase. Mag-trial pa ka to see how it performs in a real situation. Any issues found during this phase are fixed. So, maintenance. A program is fully functional. Regular maintenance is essential to ensure it continues to operate smoothly and meets evolving requirements, such as Facebook, Messenger, Instagram. Those websites or those apps are kanang naga-update siya, naga-auto-update siya sa atong mga phones. It needs maintenance is because some of the phones are not naka-on ang ilang auto-update mo na siya yung maintenance. And I think that's all. Thank you for watching.